Now let's continue our college group example, but instead of having just 4 weeks of data, we're going to have 16 weeks of data to see if things have changed. So let's enter in our data in our test calculator. So we've got 100, 105, 95, 120, 110, 95, 95, 120, 100, 105, 90, 125, 100, 105, 95, and 120. So now we have 16 weeks worth of data, and it's interesting that the average is still 105. That's the same thing it was after 4 weeks. Now after 16 weeks, we still have 105. The population mean and the standard deviation has not changed. It's changed. It's still the same. We've got n equals 16. Here we have the z obtained is 2. So it went up from 1 to 2 with these 16 weeks of data. And we have a p of 0.023 for the average. So let's change our conclusion. So we'll just copy over. The attendance of the college group was measured on several Sundays. And so we'll change this to n equals 16 after an outreach activity. The hypothesis that the group's college attendance compared to long-term attendance patterns has grown. This time it was supported. I'll change this to was supported. And z equals 2.00 and p equals 0.023. So it's supported because the probability is less than 5. Anytime that the probability is less than 5, it means that we say that's too unusual, too freaky to say that it happened by chance. So there's only a 2% chance that if the group hadn't grown, that it would have had an average of 105 after 16 Sundays. So we say we have good evidence that the group has gone. So we can even put that in there. We have strong evidence that the group has grown. Now we can't be sure because we could always make a type 1 error. With our alpha level of 0.05, that's what we compared this p-value to. There's always a 5% chance that we're making a type 1 error and the group really hasn't grown.